Good afternoon, my students. How are we doing this rainy, rainy, rainy Friday afternoon? How are we?
Sir,
It's raining.
Yes,
evening,
man.
sir.
Good
Stuck in
evening. How you
traffic.
doing? Don't
Stuck
talk.
in traffic.
JJ, don't even remind me. I am, I am also in commute. Well, I'm not in commute yet. I'm stationary. I can't move to the car because of the heavy rain. And I was like, wow. Just please, those of you are in commute, long shortcut draw blood, long cut draw sweat. Please do not drive through any alleys or any fordings. Please. The water is very dangerous, and it has been raining now consistently for about an hour. So just be very careful. All right. The rest of you that are home under your covers, how are we? So that's no answer. The rest of you, how are we?
Sir,
I
I'm
said,
good.
Nice, nice, nice.
undercovers. If them undercovers, nobody now got answer, sir.
No, but guess what? If you're undercover, you're not supposed to be in the class.
Well, you have a point there.
I'm telling you. Ay, ay, ay. All right. Where were we the last time again? It's been a minute, and we have been, me say, as you open the something,
Sorry, sir.
as you open the something, you guys are no much better than than your children, because as something open, yes, sir,
No,
let
sir,
me
I
start.
was on my phone. That's why, and it dragged.
Okay, then, all right. You are forgiven, JJ. You are forgiven. Um, existing. So why is it's not coming up? That was one. So, all right. So I have some stuff for you, but those stuff are in the car, and all the best. They're in the car. Okay, I think ready to go. Okay. All right, guys. I'm going to make a mad rush to the car. Do me a favor. I won't be the last one to be here. Give me a minute. I'll be back within a few, please. All right, students. I am not able to. I'm not able to bring up my existing whiteboard. I'm going to try one more time. I'm hoping that you got the information from before. Yes, it's not coming up at all. So I don't even remember. What was the last thing that we did? Oh, we're looking at the oh, I think I know where we are now. We're looking at indeterminate form, agreed?
Yes, sir.
Right. And the indeterminate form that we looked at um involved 0 over 0. Yes, no, maybe so?
Yes.
Good. So we now need to look at the indeterminate form, infinity over infinity. Indeterminate form, infinity over infinity. I'm going to introduce you to one very quick example of infinity over infinity. One quick example of it. And sorry. No, look, water touched me and then I'm start things already. All right, so I'm going to give you one very quick example, if only I can find it, of infinity over infinity.
Sir, we had a question as well that we didn't get to the last class.
Oh, that's correct. Okay. Um, we will need to look at those. You said we have a question, so because I'm wondering, I
Yes,
know I
sir.
did, I know I did it. So maybe this is it then. Right. Um, sorry. Let me just try and positive infinity over positive infinity. All right. So do me a favor. I'm gonna have to start a new whiteboard because this one here is not 17 or 11 with me. All right, do me a favor, JJ. Can you give me the question, please? What question was it?
Sir?
Yeah, yeah. Sorry, who was that? You have anybody has a question?
Yes, sir. It's Akila. Let me check my book, sir. So it's 2x squared.
The limit?
Oh, sorry, sir. The limit
Mm-hmm.
2x squared
As
minus
x tends to?
as x tends to 2,
Thank you, please. Mm-hmm.
2x squared
Mm-hmm.
minus 3x minus 5 over x plus 2.
2x squared minus 3x minus 5
Yes, sir. Over x plus 2.
over x plus 2. All right, good job.
Mm,
Now,
Excuse me, sir. Are you writing on the board right now? If you are, I'm not able to see it.
is anybody see my screen?
Yes, sir.
Yes, sir.
Yeah, you have to get at the top of the screen. It tell you for rejoin the whiteboard. Click on that if you're not seeing sir writing on it.
Okay.
Thanks, Colin. I can tell you hands down, why I like teaching my calculus 1, calculus 2, you guys are go-to people. Any problem, you always have a solution. Very nice. All right. So let me just talk about this one a little bit because a few of you, I think Mason was the first one who jumped out and said, "Sir, you sure you want this to be positive too? You don't want it to be negative too?" No, I want it positive too. And I want to show you something in particular. When you are substituting the limit, you're assuming that the limit is equals to 2 in this case. If you get an answer other than 0 over 0, that is the answer. However, if when you assume that the limit tends to something and you substitute and you are getting 0 over 0 and not that, there is something else to be done. A factorization, simplification, or rationalization. All right? Factorization, simplification, or rationalization. All right? So, Colin, there is, before we end tonight, I'm going to ask you to assist me with something as it relates to the recordings, right? I know somebody can ask me, sir, the recording, I tried from morning to upload the recording and I'm having some difficulties. So before the class ends, I'm hoping that I can get some resolution.
Sir,
Yeah.
Anna, you are the only teacher where I have difficulties uploading the recordings to Canvas.
Oh, because here I am thinking that is me alone.
No, it's not you alone. There's something going on with some teachers still don't have access to it. And they can't upload them stuff.
Because okay, so maybe that is all right, no problem. We'll talk off here about that one then. Because I was wondering from morning I get up and anyhow, all right. So let us go through this one now. So we're going to assume x is equals to 2. So anywhere in the function we see x, we're substituting 2. Just like this.
Sorry about that. Right. Back to it.
So 2 2 is 4 and 4 times 2 is 8. Minus 3 times 2 is 6 minus 5 over 4
Apologize for that.
over 2 plus 4. 8 minus 6 is 2. 2 minus 5 is minus 3. And no, 8, 9, 10, 11. Oh,
Sir, where the 4 come from?
I have no clue.
Sir,
Use
the denominator then is supposed to be two. Okay. Okay, sir.
use the 4 there. It's not too easy right there.
Alright, sir.
Sir, I can't check the recording.
Leave me alone, JJ. Sure. Oh goodness, I'm telling you. All right. So therefore, so what we can say now is that
Excuse me,
therefore,
Mr. Sean.
yes, my dear.
Good evening, it's Kimaya. I am
Thanks,
from
my
your
dear.
business calculus class.
Yes,
I'm
Kimaya.
wondering if this is the class that you told us about.
Yes, please.
Okay. So you start long time perhaps I'm just joining in.
No man, no man. The rain could just start. So
Okay.
you can just tell the others about it for me, please, and then let me just talk to the the calculus one students. But
Okay,
sure,
all right.
cool.
Mm-hmm.
All right. So
One
depend.
more question, sir.
Go
This is
right
being
ahead.
recorded.
Yes, ma'am.
Where can I find it?
We just spoke about that. Apparently, there's some issues, so I'm unable to upload the recordings.
Okay.
Try as I may. It's yeah, but I have a channel. My YouTube channel is Mark Shand 588. Oh, you go, guys. I'll write it on screen. I'll write it on screen shortly. All right. So just tell the others to come in, and then let me just talk to the other students. All right. Calculus one. There is I extended an invitation to the to some students who are doing block scheduling business calculus. No, they only started their class Wednesday of this week, and what it is that they are doing is what it is that you are doing now. So I invited them just to come in and can see the information, so that when I'm getting it for them, when I'm getting it to them, it is not so unfamiliar. So I'm going to ask that you just extend that welcome to them, um, as they join. They are only now starting the business calculus. Um, just this would technically be their second class. They would have completed the limits already, the intuitive approach, the calculations approach, and they have not seen the indeterminate form 0 over 0. So this is a good opportunity for them now to see the indeterminate form, infinity over positive infinity, and then I can revert to the 0 over 0 with them. So are there any of the business cal students here now?
Sir Kimaya. I'll just share the
Kimaya's.
link in the group with the others.
All right, thank you, my dearest. All
Okay.
right. So these Cal 1 students are very nice. So I know they'll make you feel very comfortable. All right. Okay, and Dahlia just joined. Hey Dahlia, how you do? Kimaya, Dahlia. All right, Kimaya, please just send out something in your WhatsApp, please, and tell the others. I know it's raining and I know it's trafficy and people may not get through, but I see them coming, so I will just continue. All right.
I'm here, sir. I was trying to unmute but couldn't unmute.
Okay, no problem. All right, no problem. No problem. So we are here
We are.
together looking at the the limits of functions, and we want to look at in particular those that are indeterminate. And I will just say this as a recap for those who were here before, and for the ones who are seeing this for the first time, that that indeterminate, when I speak of indeterminate, it means that there is something in the function, something something there. I can't tell you what it is, but there is something in the function preventing the true limit of the function from coming out. There is something in the function preventing the true limit of the function that is coming out, and we need to find that something. We need to find that something. We don't know what that something is, but there's something in the function preventing the true limit from coming out. So what we're doing, we're trying to find out what is happening. All right. So that would have been the 0/0. Students, please, when you get the 0/0, do not leave the question like that as if it is finished. Let me tell you something. We never generally give any marks to recognize that it is infinite, it is indeterminate, because we want you to recognize the 0/0. So if you just put it as indeterminate, you get 0 mark. So you have to now go and find one of the simple operations, either simplification, a factorization, or a rationalization, in order to now find what is preventing the true limit of the function from coming out. It's very, very important. Extremely important. All right. So all of you here know, both BizCal and Calculus 1 students, you are seeing something on the screen. It says the limit as x tends to 2 of 2x squared minus 3x minus 5 over x plus 2. Remembering, we are not using the intuitive approach. The intuitive approach is only going to be used when they ask us to use it. And I will show you when they will ask us to use it. Both groups, both business calculus and both calculus 1. When there, I know JJ was saying that, sir, to be honest with you, I like it because it makes sense and I can see what we're doing. I agree. I am right there with you as well. But the intuitive approach is so long because you're doing the question many times over. And what sir has been doing is doing it like 4 times on the left-hand side and 4 times on the right-hand side. So it's like doing the question 8 times. So it takes long. It makes a lot of sense, but it takes long. We don't have that length of time in the exam. So what we're going to be employing is the calculations approach. And the calculations approach is us assuming now that something is something. So what we're doing, we know the limit tends to 2. We are assuming that the limit is 2. We are assuming that the limit is 2. Anywhere in the function I see x, I'm going to substitute 2. Anywhere in the function I see x, I'm substituting 2. So look at the screen. 2, open bracket, I'm substituting the value of x to be 2. So that now becomes 2 squares minus 3 times 2, close bracket, minus 5 all over x plus 2, but x is 2. So it's going to be 2 plus 2. I'm evaluating. Bomb that says brackets, exponents, multiplication, division, addition, subtraction. I'm working my exponents first. 2 squares is 4, and 4 times 2 is 8. And that's why I have 8 there as my first term. Let's just look at the second term. Negative 3 times 2 is a negative 6. And that's why I have the negative 6 there. And the last term is a standalone. So I put it back as negative 5. And for the denominator, x plus 2, I'm going to put 2 plus 2. And when I evaluate it, 8 minus 6 is positive 2. And positive 2 minus 5 is going to be a negative 3. Please remember, when you're adding and the signs are different, you subtract the smaller number from the bigger number and put back the sign of the bigger number. When you're adding and the signs are different, you subtract the smaller number from the bigger number and put back the sign of the bigger number. So that becomes negative 3. And 2 plus 2 equals 4. So my answer is going to be negative 3/4 or negative 3 over 4. Any questions?
Yes, sir. Question, sir. Yeah, right, sir. Because I know the screen no move, sir.
All right. Colin, tell him again what to do, please.
No, sir. No, you never there right a while ago. You
Oh, no,
already.
I wasn't writing. The screen is being projected, but I
Oh,
wasn't
sir,
reading.
I see the screen, sir, but you must see attack, sir. I think it alright, sir. The screen never did not move.
He catch me there a second, but he's thinking there rewrite it. But no.
No.
Right already.
Right. I'm just explaining what it is that I have on screen. So I wasn't writing anything new. I wasn't writing anything new.
Sir,
Yes, please.
good evening, Raheem here. Sir,
Yes,
when you
Raheem.
not for this one, because this one is pretty easy to follow, but for like other equations that are longer than this, when you're speaking, can you like is there a cursor you can have so that we can follow? Because sometimes I'm having difficulty following when you're speaking.
There is, yeah.
When it's an equation that's longer than this one. I don't know if you
Okay.
understand.
I'm trying to because
All right, so a moment ago when you were explaining,
I
was following this. I could understand this. But sometimes when it's an equation that's longer than this one, and you're going through the lines quickly, and there isn't a cursor there like to indicate where you're speaking of specifically.
Okay, I hear what you're saying, but the truth is though, Raheem, all the questions we did last class on Tuesday, I believe it was, or Wednesday, there were questions that you were supposed to be doing, and then I would just come in and do those questions thereafter. All right, so I don't have a cursor on this.
Yes.
Colin is going to be looking at the computer for me. I could spotlight when I was using the computer. Unfortunately, I don't have a cursor on the tablet.
Okay.
But I would expect you though, Raheem, to be following. Is there anybody else having the same issue? No, yes.
Well, I mean, for
Let me
this
know.
one, I am.
Go ahead, Raheem.
Okay. Because sometimes I see like your name comes up at some parts. So I thought you had like a cursor.
Oh, no. I just have a writing
Okay.
device that I'm using the stuff. Right. All right. So as soon as the computer comes up, I can use the computer and be able to spotlight.
All right, no problem.
Yeah, no problem. Yeah, blessings. All right. Are there any other questions? Any other concerns that you Ooh. Is this, I know this question was done from last class, and before we left, there were a few students who were giving me the correct answers. So let me ask the question. Are we okay? I'm moving into the indeterminate form.
Okay.
Infinity over infinity.
Okay.
Speak to me.
Appreciate it.
Yes, sir. I'm okay.
Yes, sir.
All right. I'm happy for that. All right. I'm going to be looking at the. All right. So because I don't have the cursor on this stuff, do me a favor, guys. You see, if you take your eyes off the screen and you come back, you may be wondering where I'm at. So you have to be, you have to tunnel vision when we're doing this stuff here. I want you to give me your undivided.
Yeah. No, it's just asking if there's reading.
All right. So, hold on a minute. All right. What I'm going to be looking at now is the indeterminate form. Oh Lord, this thing wants to charge now. The indeterminate form, infinity over infinity. Indeterminate form, infinity over infinity. The indeterminate form, infinity over infinity. And look at what is going to happen here. I'm going to give you a question. The limit as x tends to infinity of x to the fourth. Matter of fact, let me see if you have that. Do you have a concept of infinity? When I speak of endless, okay, endless. I like the sound of that. And is it possible for anybody to name me the largest known number?
Like the type of number, as in like.
Gazillion, sir.
Yeah, but I can't say a gazillion plus. I can't say a gazillion plus one.
A gazillion. Oh.
Right. So
You're saying that means it's infinite.
It's infinite. That's the point I'm trying to make. You can't outdo me, because if you say a gazillion raised to a gazillion power, I can say to you a gazillion raised to a gazillion plus one. Right? So it's infinite. All right, let us look at this example. X to the fourth minus x squared plus 7 all over 2x to the fourth minus 6x cubed plus 2. And we're going to have a conversation on that. So x to the fourth minus x squared, that square don't look like a real square. So let it look like a square. All over 2x to the 2x to the fourth minus 6x cubed over 2. We are going to be developing a concept, and we only need to develop this concept once. Once we develop this concept one time, we don't have to do this ever again because you'll know what to do. Hear me out. If I have an infinitely large number, and I raise that infinitely large number to the fourth power, what do you think will happen?
Just continue, sir, because if it's already infinitely large and you raise it to the fourth power, raising it to the fourth power means you're multiplying it by itself 4 times.
Right.
So
So
it
what?
just keeps getting bigger, basically.
So you think it's going to be a bigger number than where we start off with?
Yes,
No.
inevitably it's going to be bigger than where you started off.
Okay.
From
Crosswell?
what time? Well, from what I remember with this, sir, whenever you have this type of problem, you'd use the highest power on
No, no,
under
no,
the
no, no, no,
denom.
no, 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 no. Hold on. No, hold on, Crosswell. No, I don't want to tell them that yet. I want to build a concept first.
Sir,
So I will soon come to you, Crosswell, on that one. Yes, please.
good evening. What are we looking at now, please?
Say it again.
What are we looking at now? I just got on.
All right. So let's continue looking. We're looking at the indeterminate form, infinity over infinity. I'm trying to build a concept. We have not yet started the question. I just have the question there, and we are trying to build a concept. So work with me. So we are saying, if I have an infinitely large number, and I'm raising that number to the fourth power. My question to you is, do you think that I'm going to get a super, super larger number?
It be infinite that change the value or how larger it can get. If it's infinite, it's just infinite. Sir, infinite time, infinite or infinite, it not change.
So it's already infinite.
Yeah, but you can
But
get
it does become a larger infinite number.
very good, excellent. It becomes a larger infinite number. If you so you remember, we're building a concept, So we know infinite is infinite. But what we're also saying is that think of it this way, layman's term. You can get an A plus on the exam. Did it mean that you got 100%?
No, because there's a range.
There's a range, yeah. So you got an A plus, the A plus may start at 90%. It means that you'd have lost 10%. So even though you got an A plus, it doesn't necessarily mean that, I master everything. There's something on the paper that would have, caused you to lose a few marks or two. All right? So think of it this way. An infinitely large number raised to the fourth power will give you an infinitely large number. Now, watch me. If I have an infinitely large number square, would it be bigger or smaller than the infinitely large number to the fourth?
Smaller.
Smaller, very good. So when I subtract an infinitely large number squared from an infinitely large number to the fourth power, I still have an infinitely large number, true or false?
True.
And when I add 7 to it, do I still have an infinitely large number?
Yes, because it's still increasing.
All right. So that's why I'm going to call that infinity. That's why I'm going to call that infinity. Let us look now at the denominator. An infinitely large number raised to the fourth power. And then I'm going to multiply it by 2. And then I'm going to have an infinitely large number raised to the third power and multiply it by 6. Do you think that my infinitely large number times 4 times 2 Rubbish. The infinitely large number raised to the fourth power, and if you're checking, I'm right here, so. The infinitely large number raised to the fourth power times 2, and when I subtract an infinitely large number cube minus 2, do you agree with me that I will still have an infinitely large number?
Yes, sir.
Yes,
I will still have an infinitely large number. When I add 2 to it, it gets a little larger, don't it?
Yes, sir. I'm following.
Good, good. So that's why I have infinity over infinity. That's how I'm going to get infinity over infinity. Now, infinity over infinity is another indeterminate form. Infinity over infinity is another indeterminate form. So, Biscal, I will show you the first indeterminate form. I did that with them on Wednesday of this week, on Wednesday of this week. I'll show you that tomorrow, Biscal. So, Biscal, you're coming in at the point where I'm starting the other indeterminate form, positive infinity over positive infinity. So when you have positive infinity over positive infinity, it is saying to you, there is something in the function preventing the true limit from coming out. So you have to go do something, right? What something we're going to do, sir? You're going to be looking through the function and you're going to be identifying the highest power that is raised in the function. This highest power could have been the numerator, and this highest power could have been in the denominator. The highest power could be in both numerator and denominator. It could be in the numerator alone, or it could be in the denominator alone. Let me say again. You're going to be looking for the highest power that is raised. This highest power could be in both numerator and denominator, or it could be in the numerator alone, or it could be in the denominator alone. Just look for the highest power. Now, tell me, which variable has the highest power in that function?
X.
Which term has the highest power? X what?
X raised to the fourth power and 2x.
So x to the fourth power
And
is
2x.
going to be the highest term in this function. Do you agree, guys?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
All right. There are some of you that are gazing. Some of you don't even know what sir is talking about. You need to pay attention. So x to the fourth is the highest term in the given function. Look at what sir is going to do. Watch me closely. Oopsie daisy. So I'm going to say the limit as x tends to infinity of x to the fourth divided by x to the fourth minus x squared over x to the fourth plus 7 over x to the fourth all over 2x to the fourth over x to the fourth oh, my pen, come on. Sure. Minus 6x cubed over x to the fourth plus 2 over x to the fourth. Can you see what I did right there?
Yes, sir.
Somebody verbalize for me, please. What is Simi do right there, so?
Sir, you put everything.
Sir, you put the denominator and the all the terms from the numerator over x, the highest power or term with the highest power over the denominator. I mean, yeah, basically with the numeric as well, doing the same thing.
Okay. Everybody agrees with what you said?
Yes, sir.
Yes, sir. Can I ask
Good.
a quick question?
Sure, right. Go ahead.
How is what this read? Infinity extends to infinity. That's what the left hand corner is saying.
Extends
Or
to
x
infinity.
is that a x?
Yes. Leave me
Oh,
alone.
sorry. All right, no problem.
And don't shame my handwriting. Yeah, man. It's a x. So x tends to infinity.
Sir, I am lost. Why you use x to the power of 4? Why did you use 7? Isn't 7 higher than x4?
No, 7 is a constant.
So we're supposed to focus on the x.
7 can't go up, 7 can't go down because 7 is a constant. You follow what I'm saying?
No, sir. I'm asking if we're supposed to focus on the x that has the highest power, and not to what do you call it, constant?
$7 for your pay because it's constant, right? So 7 is a constant. You're not getting anything out of it. You're not getting anything out of it, right? So the constants, the only thing that moves really are the terms with the variables, and the higher power variables move much more rapidly. Remember when we had COVID, hold on a minute, please. All right, so sorry about that here. So very good. So remember now, 7 is a constant. A constant is a constant is a constant. It don't go up, it don't go down. It's just a constant. Watch me now. I don't want anybody to write. I want you to look at what is happening right here. X to the 4 cancels X to the 4. X to the 4 cancels X to the 4. X squares cancel that and leave 2. All of this cancel that and just leave one of that. And then this is what we have.
Well, I understand my blink. Do that over.
And you,
Yes, sir.
I
Please
like
go
what
over that one.
I like what you say, you know, you blink. That went very quickly. What I'm doing is just canceling out. So the X to the 4th over X to the 4th cancels out. And then
Okay, X cancelled X. The
X
2
squared into
cancelled
X to the
4.
4th goes, leave a remainder 2. So
Mhm.
this is X to the 2nd power for the second term. I cannot cancel anything from the 7 because there's no variable to cancel it from. And then now in the denominator, X to the 4th cancels X to the 4th. Sir R, are you following me?
Yes, sir. Let's see it.
Okay, good. And X to the 3rd into X to the 4th leaves 1x, don't it?
Yeah.
Yes, sir.
Good. So this is what I now have. The limit as x tends to infinity, x to the 4th divided by x to the 4th equals
1, sir.
equals 1 minus 1 over x squared plus 7 over x to the 4th all over 2 minus 6 over x plus 2 over x to the 4th. All right. So somebody asked a question earlier. In normal love when students ask questions. And I'm going to ask you now to look at something for me. Look at all the fractional forms. Look at all the fractional forms. And tell me what you notice to be common in all the fractional forms for the last line I wrote.
The term X.
The term x, is there anything else?
And
The denominators.
yeah, the denominators.
What about the denominators?
And their power, they always, well.
Hmm?
Mixed function.
What about the denominators?
Sir, X square, can say X square is common.
No, sir. X squared not common to x in the 6 over x.
So that's
That's not what
X.
that's not what I'm looking for still. Tell me what you see that is common. Oh, no, look on this of the man story. Look and tell me what you think is common.
So the variables are in the denominator position for the equation.
And
They're divisible by x.
By
yeah, but what else? Yeah, so the variables are in the denominator. Yeah, what do you recognize again? That what?
They're divisible by x.
Yeah, same thing. The denominators are contain the x's. Yeah, but what else? There's something else.
the powers.
Yeah, even numbers.
What about what about whole numbers? Hmm? Students, you are multitasking. I don't have your full sum attention, and that's why you're not
We
answering
have
me.
positive and negative whole numbers.
I agree, sir. I mean transit, so I apologize. It seems like I can get it in, sir, but just because I'm sharing my attention right now. But
Yeah, man. I cannot
when
see,
you
and I
send
can.
me the thing, me go. Let me
Sir,
go back home.
numbers,
I understand it thoroughly when you send me the thing in it, sir.
Mhm. So tell me now, and fair enough, Dahlia. So tell me now. Look at the thing. You no matter looking at that. I mean, why you're gonna look up nobody. Look at it
Oh, you know, sir, that nearly happened a while ago.
Oh Jesus, Osh. Look at the fractional forms and they're right in front of the face. Tell me what is. You told me one of
sir,
it already. Tell me the other
sir,
one. Mm.
sir, the top numbers never change.
The top numbers what?
Never change.
Okay.
Numeric never
All right.
change.
Is the closest I get to what I want. It's not what I really want yet, but it's the closest. Talk to me. What you recognize with the top numbers?
All of them are numerators now.
No,
I
Actual.
can't remember the type of
Variable
fraction.
X.
They're divisible by 2, sir. The whole numbers are divisible by 2.
No,
Mm,
7.
mm,
That they're all constant numbers.
So they're no longer coefficients.
mm.
So I think yes, sir, you mentioned the type. I guess it's a type of fraction that they are.
Somebody asked a question about the 7. What did I call the 7?
A
A
constant.
constant.
A constant. Jesus. So do you
Sir,
agree that the numerators for those
Are all
fractional forms are
constant.
all constants?
Yes,
Yes.
sir.
yes, sir.
So,
Sir, that me that chance, but never
so
remember.
that's why I say to you that you're the closest, Colin.
Yeah.
Mm. So the numerators are all constants. Now think about it. Think about it.
Oh.
Say, for example, I have 1 and I want to work with. If you want to grab your calculators, I don't have a problem with that. Say, for example, I have 1 in the numerator. And then I have x squared in the denominator. Sorry. I'm not squaring it. I just have 1 over x. So this is what I have. 1 over x. All right? So the 1 is constant. When x is 1, I'm going to have what?
1.
Which is 1 over 1, don't?
Yeah. 1 over 1.
When x is 2, what I have? Mm-hmm.
That's how when x is 2, half. Oh, okay, yeah.
Sure, you asked a question there, right, sir?
Yeah, that's all right. When x is 2, 2x.
When x is 2, what do I have?
1 over 2.
1 over 2. Duh.
Oh, that's funny.
When x is 3, what do I have?
1 over 3.
1 3. 1/3.
If you tell me 1 3, see, I take your lunch money. When x is 100, what do I have?
1 over 100.
All right. Now, let me just help you out here. 1 over 1 is 1, don't?
Yes.
Yes, sir.
1 over 2 is 0.5?
I do the approaching to 0 thing, don't it?
Very good. 1 over 3 is 0.33 and more 3s. 1 over 100 is 0.01. Uh-oh. Look at this. Starting from 1, where I end up, 0.01. What can you say about it? Somebody just said it.
Getting smaller.
Smaller.
Further away from 1.
Well,
And give me a nicer term now. Come, Nigel.
It's to
Right
0.
hand side, sir.
is it approaching 0? Is what you're looking for, sir?
That you want me to say, sir?
It's approaching 0.
Oh.
I like how the line there go to the right instead of the
It's approaching 0. So guess what? You see the bigger the value you have there, it's going to go 0. And remember, You may say to
Oh,
me, sir, oh, you know, say the value get big. Remember, say we are going to infinity, you know. And
so,
infinity, say the value will get big. So watch me. Watch this statement. As
Thermal.
Okay. Talk to me. Where did I lose you?
Yes, right. Where you have how you is it that the one X that you have here is it how you get the one?
Oh, I get this?
Yes, sir.
example.
Yeah.
Yeah, example.
Yeah, it have none to do the limits extend to infinity on the left hand side.
Oh, okay. Oh, I guess I still didn't get the example.
Right. I was just explaining. I was just giving you an example of what it is that is to come. You follow me? All right, students.
Yeah.
So question, sir.
Mm-hmm.
So if the fraction them are going to approach zero, that means only thing with the left back are the constants.
Very good.
Yeah.
Excellent. At least I know one student. At least one student is listening and paying
Can you
attention and thinking
repeat
ahead.
that, Nigel? I think that's all.
No, I never me this time, but I agree with when, sir.
So watch this statement. So as x tends to infinity, 1 over x squared, comma, 7 over x to the fourth, comma, 6 over x, and 2 over x to the fourth. All tend to 0. All of those going to tend to 0. So this is what I now have.
1/2.
Very good. The limit as x tends to infinity, I'm going to have 1 minus 0 plus 0.
I still have to write that part there too, sir.
Yeah, man.
Judge.
So what I was doing all along was building the concept of the indeterminate form, infinity over infinity. I was building the concept of the indeterminate form for infinity over infinity.
But you know, technically still, sir,
Mm-hmm.
the example where you give up on the right hand side kind of give the answer, you know.
It sure does.
Because if you have a infinitively larger number
Mm-hmm.
as the divider to a constant,
Zero.
Zero, yeah.
Zero, yeah. So that is a concept I was building. So this here is a concept. I was building a concept and I wanted so let me just go through. I want all of you, as best as possible. Don't have a computer with the mouse and the stuff. So I want you to pay attention here, please. The limit as x tends to infinity of x to the fourth minus x squared plus 7 all over 2x to the fourth minus 6x cubed plus 2. That was the question that was given. What we are going to be doing in order to do the question is to take note of this, that it is going to x is tending to infinity. Very important. That gives you the indication as to what to do. So from me to that, you know what to do. It's going to infinity, but sir, we can't use the calculations approach. No.
Oh.
Because you don't know if I put in there.
Okay, I'm getting now, so I'm getting.
Yeah, you don't know if I put in there, so you just have to go work it. So what you're going to do is you are going to look at the function. You're going to look for the term with the highest power. Now, hear me out. This term with the highest power can be found in the numerator and denominator alike, as in this case. It can be found in the numerator alone. It can be found in the denominator alone. So you have to look carefully to see which is which. And the highest power doesn't have to start at the top of at the front of the function. The highest power could be found in the middle, and the highest power could be found at the end. So you have to investigate properly, thoroughly, where it is that this highest power is going to be located. Once you have found the highest power, every single terms in order something is going to be divided by this highest power. Every Jackman is going, sir, all the constant, yes. Every smuddy will be able to be affected by this division by the highest term, the highest power. So watch me. The highest power in the numerator is term with the highest power is x to the fourth. And I'm going to look at the denominator. The term with the highest power is another x to the fourth. So all 6 terms are going to be divided by x to the fourth. Now, when I divide it by x to the fourth,
Sorry.
I'm going to go ahead.
Sir, I have a question.
Go ahead.
Oh, never mind. Doesn't really make sense. But I was gonna ask, for example, what if the numerator was just x to the 2 and x to the 2 and only the denominator had x to the 4th? Would the x to the 4th still be used for everything?
Yes, ma'am.
Okay, so
You're dividing throughout by the highest power.
Yeah, not what is the most.
Right.
Highest power.
And again, this highest power can be found in the numerator and the denominator alike, or it can be found in the numerator alone, and it can only be found in the denominator alone.
All
All
right,
right?
Sir Sean.
Please, go ahead.
Sir, can you explain the line above the answer, please?
Yeah, man, I'm coming there. I'm going to the whole question.
Okay.
Mm-hmm. So now what we're doing, having found our x to the 4th to be that value or that term, I'm going to be dividing every Jackman by x to the 4th. So it's going to be x to the 4th over x to the 4th minus x squared over x to the 4th plus 7 over x to the 4th. But sir, this 7 have nothing to cancel off with it. I don't care. Am I going to get divided by it? Next, 2x to the 4th divided by x to the 4th minus 6x cubed divided by x to the 4th plus 2 divided by x to the 4th. See me so. Now, I am going to see what is common and then do a cancellation. So the x to the 4th over x to the 4th will cancel. Please, in Jesus' name, do not write 0. X to the 4th divided by x to the 4th is not 0. But sir, it don't leave anything. It does 1. And then x squared divided by x to the 4th is going to give me 1 over x squared. Because I'm taking 2 of the powers from up the 2 in the numerator and robbing 2 of the powers from the denominator. And then the 7 is going to be divided by x to the 4th. In the denominator, the 2x to the 4th is going to be divided by x to the 4th. So does the 6x cubed. So minus 6x cubed over x to the 4th. And x cubed divided by x to the 4th is just simply x. So I'm going to have 6 over x. And finally, we have infinity over infinity. From the 2x, the 2 over x to the 4th. Hear me out. Hear me out. Once you have a constant in the numerator and the denominator is getting larger and larger, what you're going to have is that function, that fraction there is approaching 0. And that's the concept that I was building earlier. Your numerator is fixed. Your numerator not going. Think of it this way. You have X amount of money on your investment. And every day you got on the gun, draw, and now put back nothing more up in there. What gonna happen?
It's going to be depleted, sir.
Yeah. You're gonna reach 0 sooner than later. Same thing with the maths right here, so. And then the 2 divided by x to the 4th is just going to be 2 over x to the 4th. So where I'm at just now is this line. That's the line I'm at now. All right? Now, continuing. Somebody asked a question, sir, can you speak about the line just above the answer, please? No problem. So we are saying as x tends to infinity, as x tends to infinity, as x gets large and in charge, all of my fractions are going to go to 0. I just prove it right over here, so in my concept building, once x gets large, the fraction is going to go to 0. So therefore, I can say 1 over x squared plus 7 over x to the 4th, and 6 over x and 2 over x to the 4th will all go to 0. So therefore, 1 minus 0 plus 0 is 1. And 2 minus 0
So
plus
you're not
0
writing
is...
anything?
No, I'm not writing anything. I'm explaining.
I can't see what we're going on.
Sir, question. The x 6 over x, what is that beside the 6 over x?
It is called the ampersand sign. It's the and sign. Let me write it like how you're accustomed to write it.
The whole time I thought it was a plus symbol.
Those who went to good school write the ampersand sign like that. And those who went to the other schools write the and sign like that.
That's crazy.
Don't follow the teacher here. Is it clear now?
Yes, sir.
Yes, sir.
Sir, so based on the concept to the right, that the greater the variable with the power, it's approaching 0, you then group all of the fractions. and
set them equal 0.
set them to 0, and then you work out the constant, which is 1 and the 2.
Yes, I.
Okay.
But it would not be a nice math class if you don't get one to try on your own. And then.
Bring it, sir. Bring it.
And then.
Try and look.
I want you to look at some stuff. And we are going to solve these questions by inspection because I'm teaching you to look on something and can tell what happened to it. So let's go. You're going to write a question. Número dos. Número dos. The limit as x tends to infinity of x to the 4 c minus x squared minus 9x cubed all over x to the 4 plus x cubed. So the limit as x tends to infinity of x to the 4th minus x cubed minus 9x minus x squared, sorry, minus 9x cubed all over x to the 4th plus x cubed. I'm doing that so that you can see both. I want you to do that question for me, please, and thanks. Students, make sure that you are giving an attempt to the question. All right.
Sir.
Go ahead, please.
Where you have as x tends to infinity, that's the third thing, the first thing after you have the asterisk there. You say you group all the fractions and assume that they're equal to 0, or say to 0, and that's where you substitute 0 into the equation above to have 1 minus 0 plus 0 over 2 minus 0 plus 0, which gives us a half.
Yes, ma'am.
Okay.
Good job.
So can the answer be 0?
I guess so. Yeah, man. Not remember we established that 0 is different mathematically in calculus than 0 over 0, don't it?
Yes, sir.
Remind the class when Nigel what 0 over 0 represent again?
Indeterminate, sir.
Okay. Good job.
Yep.
How we feel? Still working?
Yes, sir.
Yes, sir.
Service and embassy, if that's right, please.
Shani, that's so like you, but oh, okay. You know, I look at it and I thought it was an I. Forgive me. Very good, Shan.
What is
Very nice. I have one answer so far, guys. Come on. Waiting on anybody else to say the finish.
Sir, I get 1 for the answer.
Okay. I
Finish,
just
sir.
wanted. What do you get for the answer?
The same one.
Okay.
Sir, am I close? Am I right? Am I wrong?
That's the first stage.
Sir, also the same answer, sir.
So hold on. Sir, what you say a while ago? That's the first stage?
Yes, sir.
Aye. All right, sir. Next page.
Anybody else? Need more time?
Yes, sir, finish.
Sir, I get one
Yes,
as
sir.
well.
All right, I give 2 more minutes. 2 more minutes and that is it. Hello.
Yes, sir, I'm finished.
I don't know. Sir, I'm get -9. I don't know what I'm doing.
It's all right. Hold on to that.
I'm still working.
All right, let's go. Are we all aboard?
Yes, sir.
Yes, sir.
Uh-huh. So you will all agree with me that this two is going to be indeterminate, zero, infinity over infinity. Anybody at the point where they don't know who I got that to be so? So you just write it down. I tell you, so when you see it one time, you just write it down. So you know it. It tends into infinity. It's not tending to a number that it can go ahead and substitute. Tending to infinity is of the indeterminate form. Talk to me now. What's my next step?
Sir, find the highest
Very good. Term.
term. Yeah, the highest term, which is 4x.
X to the fourth.
X to the side. X to the fourth.
So why you have limit tends to 0, sir?
Hmm?
Why you have limit tends to 0?
You see that? In Angel, you see that, Angel? No, sir. You know, sir, I forgot to get some glasses for Angel, you know. Angel, thank you, Papa.
Good comeback, sir. Good comeback.
Angel, let me tell you something. I don't know what is happening to me. Yesterday, I was on fumes going to work. And I said, not a problem. I will just stop off at the gas station. You see, when I fling my hand around at the back of the car, not a wallet. I was like, therein lies a problem. Because the traffic to go back home is equally the same traffic to go to work. But of course, you have to go to work. So I went to work. And I prayed to God to the car could I take me back home to get that wallet to go get gas. That okay, it worked well. That was yesterday. This morning, got up, left my cell phone at home. I said, okay, fine. I
And the
can live.
computer.
I can. And the computer. Oh, thank you, Colin. And the computer that Colin's supposed to get. And then now, when I got to some place and was putting on the seatbelt, my hand brushed against my waist. Me no left all my belt. Me say, no, man, something wrong, man, something wrong, something wrong, something wrong. I don't know if I'm just tired or what, but I'm forgetting.
Or, sir,
And
the week done, sir.
me for tell you, man, I should have dip on the North
The
Coast now.
work week finish.
I should have dip on the North Coast now, you talk.
Sir, I can't do a swear, man.
No, man, I'm not Christmas ready, man. I've class on there and say, okay, students, I'm ordering, yeah, that what I want.
Can't wait for Gamma Bit. I'm so
All right, come, let's go back. And then now, we're going to have x to the fourth over x to the fourth plus x cubed. You know, students, this is not hard, you know?
Yes, sir. We get the party. Get
It's
the
not
party.
hard. What am I
And
going to know?
then
What am I
we're
going
gonna
to know?
cancel out.
Yeah,
Then
man. This cancel this. All of
yeah.
that cancel that and leave 2.
Yeah.
All of that cancel that and leave 1.
1, yeah.
That, come
Okay,
on,
so
Ken,
let's
don't
have
do
an
this.
x to the 4.
Huh?
So let's have an x to the 4 under the x cubed.
What is wrong with you?
Yeah,
Aren't you
man.
seeing x to the fourth?
Yeah, seeing it now, sir.
Good. Thank you, guys. You know what it says to me? And I feel good. It says to me that you're paying attention, and that's very encouraging. Very nice, guys.
Sir, I'm not seeing it.
You're not seeing what you're not seeing?
I'm right. So I'm on to new. So I'm not seeing from it's a limb. How you got the fraction over the fraction?
You just John about the TT?
Yeah.
Okay, all right. You stay put. You go and look. We're going to do many more of these questions. So you can pick up from where we drop off here. So let's go and look, my lovey. And then now, you can have the limb. Oh, come on. You see when you have to change back the color because you make a mistake. Then we have the limit now. As x tends to infinity, x to the fourth divided by x to the fourth is going to be 1 minus 1 over x squared minus 9 over x all over 1 plus, nope,
I divide. Zeros over zeros, man.
Yes, sir.
No,
Mr.
sir.
McLeod, no, sir.
It's all right.
Some
It's Friday
error.
evening. It's Friday
Some
evening.
error. Some error.
So as x tends to infinity now we're applying the remember, it is indeterminate, So we're going to do a simplification, a rationalization, or a factorization. Were we factorizing? Say no.
No, sir.
So we're doing a simplification. So we're simplifying this stuff first before we then go ahead and add and apply the limit. Now we are applying the limit. The limit as x tends to infinity. Then I'm going to have, comma, then 1 over x squared, 9 over x, and 1 over x all tend to 0. Every one of them. So I'm going to have the limit as x tends to infinity. I'm going to have now 1 minus 0 minus 0 all over 1 plus 0, which is 1 over 1, which is equals to 1.
So how you know it's 0?
1 is 0?
Yeah,
Because
to the second to last part.
Because it is you're talking about the part that says as x tends to infinity?
Yes.
See it right there, sir, the concept. I have 1 over x for argument's sake. I'm bigifying it so you can see it. I have 1 over x for argument's sake. Now, if x is 1, 1 divided by 1 is 1. Talk truth.
Yes, sir. 1 into 1 is
Yeah,
go 1.
but she not answer me. I should ask one question.
Yes, sir.
Yeah, you may talk to see if I answer teacher. When x are 2, 1 over 2 equals?
0.5.
0. There you go. And when x is 3, again have 0.3333333333. Continue. And then me say, all right, me see what I want. And then me jump the gun and say, you know what? 1 over 100 is 0.01. So tell me, I'm moving from 1, I'm moving to 0.5, then 0.3, and then if I do 1 over 4, I got 0.25, and if I do 1 over 5, I got 0.2, 1 over 6, I got 1 point something. You recognize now that as I move to the right, I get smaller and smaller until I reach 0.
So, sir,
Because,
if you had put 1 over 1,000, it will be
oh, Jesus, that's exactly what I was going to put, Papa.
0.0001.
That's exactly what I was going to
So,
put. 1 over, matter of fact, I can put 1 over 10,000. Then again have 0.0001.
so sir, that means that it's always 0.
Very good.
Okay.
Excellent. So it
And we
will,
can scroll back, we can scroll down and look at something. So for this one down there, that states as x, whatever,
no,
then
not tell me no
1,
whatever. Read it. As x tends to infinity.
as x10.
To
That's
infinity. No,
something there.
me say more you say it. As x tends to infinity.
As x10 to
Tens.
infinity.
Mm-hmm.
Tens
Mm-hmm.
to infinity.
Mm-hmm.
Then 1 to the power of. Sorry, that's something there. Sorry, let me ask you, see. So I basically would divide. Well, I don't know what to say. Sorry, continue. Right?
No man, talk to me, no man. You have conversation with me and then you go talk about no man. Talk to the
Sorry,
teacher, no man.
I don't know how to explain it.
It's
How
all
to
right.
ask you, so
Me tell you say you ask me foolishness. Ask a question.
Yeah, I know how to state it.
All right, then cool. Maya?
Yes, sir. Going back to the concept, if to understand this, I'm thinking just to have it in the back of your mind so you can remember is when we're doing the algebraic approach where we assume the value of x, it's like, and this is infinite. This is the indeterminate up where we say the infinite. So we can assume that x is any value, which is, and these are, we are trying to get we are trying to assume the values of the fractions. So with the example, with the concept of 1 over x, then we'll just assume that x is equal to any number, any random number, infinite number. And that's
very good. And you hear what they say? Any random number, the infinite number, any large number you can think it, are your business. So if you're a large number 10, that's for your business.
Yes.
Are you still seeing my screen, guys?
Yes, sir. Sir.
Okay. Yes, Jay.
Sir, can I tell you that I could not work out anything a while ago because I was in walking, but yet still I looked at the equation and said that looked like 1 over 1. And I
Very
didn't know it
nice.
was true.
Very nice. And that's exactly where I'm gonna go now. That's exactly where I'm gonna go now. Me don't teach no, you know. A phone work no. Remember, you know. You all going to be doing reading for your degrees now. So can you do these by inspection? That was number 2. Okay. I need to make up one. The limit as x tends to infinity, 2x to the 5 minus 9x squared minus 7x all over. Call that 5x to the 5th. And call that, say, 2x. Can you look at that and tell me by inspection what is the limit, please? Where the limit is going?
So you want the answer, you want it?
Answer.
2
In
over
5.
2 over 5.
2 over 5, are you sure?
Yes,
Sir, you
sir.
can scroll down, please.
Is that okay now?
Samuels, you have to scroll down your screen.
Oh, thank you for telling me.
Thank you.
Any everybody agrees that it's 2 over 5?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Is there
sir.
anybody in the class that don't agree?
So we said 2 over 5. What you say, sir?
Well, I'm gonna agree with you and call it 2 over 5. Very nice. Very nice. You know what is concerning though? There is at least one person in the class who don't have a clue what going on. And them now say something.
Me say something. I'll get 2 over 5.
Okay.
Yeah.
All right. Thank you for being honest though. You can get the 2 over 5? You can go through you can write off the question there. And you can go through all of the steps and tell me what you get for your answer.
So I mean, if you sit down for you know, so I mean, I know what a clock a strike. I mean, know me, I drop the bomb pan.
You know, I thought you were asleep, honestly.
So me just come in my rain back me up.
Gosh. All right. And even those of you who correctly said 2/5, I still want you to work the question to prove it. Because guess what is going to happen? Even when you're going to the exam and see what the answer is, you can't just write 2/5 and expect to get 5/5. You have to work it. But guess what is the good thing about it? When you're able to inspect it, you're able to work and you're working towards an answer. So if you're not getting 2/5, you know, say there's something wrong. So there's no way I can give you a question or questions and a failed exam on this because you know what I'm going. All right, I'm sure nobody will get this one, but um, I'm sure nobody will get this one. On the mark gets it. What's the answer for that?
Three.
3/1 or 3?
Yes, sir.
Well, that's a 7/, -7/2, but I don't know exact number
Why,
yet.
sir, when you come later class, why you pay?
Sir, is it the
Sir, me
7/2?
Yeah, we said -7/2, sir.
Yeah, -7/2.
Yeah,
I
look like
think all
that.
of Daniel.
Look like that.
Sir, me not bother do me not bother do business calculus until next semester, sir.
Sir, me reach home late, sir, and boy, me a pay. So I don't know what is happening. I may
All
a
right.
try and me not see it.
Kenny, you see? Why need
Jesus, God, me stress.
no, wait, hold on. Never mind. You see it again, no, Kenny.
Mighty God.
It's just that I wanted you guys to join the calculus students to see what is happening. But I'm bringing across this point, and I understand that it rained today. Don't think that I'm vexed and I'm cussing. No, that's not the aim. Because you know I was also caught on the road in the rain. But this when you come into my sessions class, gonna have to come quick, because sir gave you, I normally give you guys 15 minutes grace period. All right? Because it's when you come in late, best believe say my session go teach. My
Fair
session,
enough, sir.
my
Been on
session,
the run since 3 o'clock and my reach home
Fair enough.
like
no,
6
man.
basically.
I am not upset, because I know it rained and the roads are awful and the traffic is awful and the whole stuff. No, man, I understand that. I understand all of that. And that's why I am going through what it is that I'm going through. I'm asking you to do this by inspection, but nonetheless, I'm going to ask that you still do the calculations, because when you go into the exam, you're going to be needing to show me your calculations. But Raheem, was it you who said -7/2? I'm trying to figure out.
Someone first, mister. I was the second person.
Or who first you?
I don't know, I didn't see the name.
Yes, sir.
Me
Oh,
who?
Brown.
No,
Okay,
bro.
Brown.
Sir
Akeem,
Shand,
yes, please.
I don't catch that part there. Sorry about that. But me
Don't
might
worry
catch
about it. You
it
soon
there.
catch it, man. You soon catch it. You soon catch
Alright.
it. Um, the truth is, Kenny, I don't want to show you what to do. I want you to see it and figure it out on your own.
That may do, sir. The water there, the tip, but the on my eyelash because the end hurt me. It's stress.
Never mind, never mind, never mind.
Oh my
Um,
God.
so
Sir,
what?
the last part, I see how you, when you guys were reducing and all that, but the zero part, oh God, don't there's something,
All right.
not catch it.
There is. Don't worry about it. I'm going to go through that again, man. All right.
All right.
Alright, sir. No worries. Me catch it now.
All right then. Cool.
See
But guess
there?
what? Though?
Jesus, it look
But
like
guess
this.
what?
So,
I don't want anybody to tell anybody what it is. I want them to figure it out. If afterwards, by the end of the class, you still don't figure it out, then we'll tell you.
all
So
right, sir, I'm gonna try.
this is discovery learning. I have more to give you now, but I want to say something. Yeah, man. I know I think the class done it. We have one more number of 57 minutes. Work with me.
May I work, sir? May I
So
watch?
the two gentlemen who came up first with the stuff, I was listening on the phone, you know. I mean, hear somebody say, 3/1, sir. I say, no bug, I want to get catch. What caught you right there when they said 3/1?
Sir,
They look on the left side.
They look on the left side? No, man, I know that's what I do.
Yeah, man, we can slow up there.
Sir, the X to the fourth power catch me.
Sir.
That's right. That's what caught you.
We
The
kinda
X
leave
to the
it there,
fourth power.
Yeah.
So you weren't looking through the function properly to recognize that X to the fifth power was all the way over that side here.
Exactly.
And it bigger.
Sir, may I
So
learn? We get it.
you get it now?
We get it.
All
I learn.
right. Yes.
2/5. We get it. We get it.
All right. Okay. Kenny, you try or try and get it to know or else. All right, come watch this one now.
Sir, may I tell everybody I get it on boy?
No man, you soon get
Still
it,
I
man.
look, sir. May I go get it? May I look?
All right. So here goes
Sir,
one
can I
more.
catch us again?
Make Allah you tell. Watch this. I bet you nobody can cross this. Watch this now. Watch this now. Watch this now. Watch this. What's the answer?
4/2.
4/2.
4/2.
2.
Yes, sir.
What's the answer?
Which should be 2.
4/2,
4/2
sir.
or
Yeah,
2.
4/2, which should be 2.
Blow. Whoa. Nice. Can you see that down, Kenny?
And I know what kind of black magic.
Sir, sir,
that
may I go sleep?
different.
Sir, this no fear. Not catch it. And them get your
Sir, you
student them
can't
bright
catch me
man.
again, sir.
Jesus.
I mean, I can't catch him again. Who said we can't catch him again?
Sir, you can get back in sir.
Me a bet not Tigers. Me a bet a Tigers.
No, man,
Roderick or Dahlia.
No, Dahlia
That's
driving.
2025, sir.
Oh, Dahlia driving. My
You're
goodness.
2 bills credit, man.
2 bills?
Can you show all no me
I
not
mean-
go? Then make sense you call me, because I can't help you neither.
The water the palm island. Me just need for Quinton it drop. Stress.
Oh, goodness. All right.
And then just I look on the question and I tell the answer. So, oh my God.
All right. All right. Now, so the youth say, you might bet me a Tigers, a $200 Tigers.
I never said.
What you say?
No,
I
I say
win
you
Tigers
will
for 200.
keep some money on the table.
Oh, what's the answer?
Right.
Bam! B win. Pass my money.
Give me a
Yes.
text, sir. Don't work it out.
No. It's by inspection. Give me my
Sir,
money.
Sir, is it 1/1?
Nobody
No.
can cross it.
There's a 0.
What?
Is it 0?
What 0?
0/0.
Sir, 3.
No. Ha 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 ha.
0/1.
Who said that?
Sir.
Lambert.
Oh, you catch your afraid today, Lambert. Eh? Lambert, you catch your afraid.
Oh, sir, I've been here, sir. Been trying to answer when I can.
When you can, you should be answering all the time. So Lambert is correct. 0/1, which is the same thing as
Sir, break it down, please.
0. Got you, Lambert. Yeah.
Yeah, the man, thief.
All right. I can write many more, but I'm
Yes,
not
sir,
gonna
I
write
see it,
any
sir.
yet. I'm not gonna write any yet. Matter of fact, I'm gonna write one more. Let me ask you now. I'm posting these 4. For those of you who don't see it yet, I'm gonna ask that you look at it, look at the answers, and I don't want nobody to help anybody. I want them to discover it on their own. Look at the something. And I'm going to give you, matter of fact, oh, I did say that. Students, I am not into teaching you how to do the limits by inspection. You must know how to do the limits, because if you're going to the exam and do the limits by inspection and give me and things, you can get 5 out of 5. Dog, now me supper, you know, because of 1 out of 5 I get for the answer. So I'm only showing you this so that at least you can work towards the answer.
So this is
So
a
what?
final exam question?
Yes, I for 5 marks. You can get a question like this, or questions like this, Roderick. Questions like this or like these. A B C D. A B C D. Yeah. 5 marks each. So this is like a 20-mark question. Them set a question is like a 20 marker. Real talk. Or worst case scenario, they may give you 4 marks and call it 16.
No, we may have to
But
catch it then, sir.
you have to catch it. So what I want you to do is, um, what I want you to do is, I want you to work out the question. I want you to work the question, so that you can, have an idea. Sorry, Kenny. Can somebody just screenshot this one for me, please, so that you can have that to use to work out the other question to me?
Yes, sir.
Just screenshot that piece up there, so that thing up there.
The purple one?
Yeah, screenshot it for me, please. And then when you screenshot it, let me know.
All right, it's done. I will send it in the room.
All right, great, thanks. Then now I want you to work these questions. I want, even though the answers are there, I want to work it. By the end of working these questions, I still don't see how to read it by inspection, all of you. Then we'll have a conversation to show you how to read it.
Yeah, sorry, my just work out number 4. I get the answer. I still can't see it by just looking for it. Man, I understand. Oh, go on.
Oh, but you work out the last one, and you got it. Which number 4 you talking?
Number 4 right there, so where it say -7/2.
Oh, okay. So you're not seeing it, but you work it out and get -7/2.
Yeah, I get it.
All right, no problem. I will show you, Colin. I'm happy that you work it and get it. Okay, guys, I'm giving you 2, 4, 6. I'm giving you 10 minutes to work those 4 questions. Them easy. Now, hear me out. You see the part where them say, as x tends to infinity, which fraction and which fraction and which fraction and which fraction tends to 0? You better write that statement there. You get a
Yes,
mark for that.
Yes, sir. I write it down. I write it.
Good. 10 minutes. On the mark, get set, go. Good job. I'm happy for that you're finished. But do me a favor though. I'm giving the others enough time to finish off the work. As I said before, it's good that you can see it by inspection. Um, but you also need to be able to work it. If you do the questions on the exam paper by inspection, you're getting the mark only for the answer. Don't think you can get full 5 out of 5. You're going to get 1 out of 5. So I give you another 5 minutes to just finish off the stuff quick and fast because I have something else to look at.
Sir, question.
Go ahead.
I can look in the chat. I sent you a message.
Okay, no problem.
Sir, can I ask you a
Yeah.
question?
Right ahead.
When you have 1/1, is it just one?
Mm-hmm.
Okay. Go wrong. One is one. Okay, sir. Finish.
Good job.
100%.
Nice. That's the spirit.
Finish, sir.
Mm-hmm. All right, guys. Another minute. Another minute, please. Time is going. Another minute.
Okay, so I'm just have to figure out the pattern from inspection.
Good job. Ready or not, here I come. All right. How we feel? Were we able to do the questions and got back the same answer?
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Okay, because if you thought that I was going to do the question again, when I don't know how to do the question, and make a sad mistake. But let me answer. Kenny, are you here now, Kenny?
Sir, can you over here crying?
I wanted them drop out it, Kenny.
Right out, sir. No joke over here. Me not get it.
It's all right, man. We so link you. We so link you, man. You're good. All right. You know what I did? Just for the class, I
Call in your
Karen,
mic.
mute your mic. I can't eat your eat.
Yes, get hungry, man. I use too much brain power.
was that Shanika? What? Hey, Shanika, you know, say no behavior. Shanique, me, I try with you. Oh. All right, let's go. The oh my goodness, I look forward to my Friday evening class. Trust me. All right. You all won't get this. Hey, Siobhan, I was gonna comment on it, you know. But next thing, Shanik go call me big back because my time say send on to other chicken wing they coming over. But me no, Shanik go say no, sir, you're a big back.
Morris said the American himself, so I don't know what that actually means.
I said go. All right.
Yeah, all the Americans in here know yourselves.
Well, my family has called me that several times, though it hurt my feelings. So, is it true? Me never want to hurt my feelings tonight. Me say no, what me not beg none, yeah. Big back theory. I was like, seriously? Yes. I was like, ouch. All right, let's go. Anybody who figures this one out and tell me the correct term for this, I know you're on your way in passing this course and passing the course very well, as a matter of fact. What's your infinity? Anybody?
Just start skip through the notes and I see zero.
No, infinity.
I do want to go now. What's up? Do I know enough?
Sorry about that, sir. But I look for the question.
No, not no, if that's not it, somebody come and tell me the answer.
It's looking like 6/0. But
who is that?
Lambert again, sir.
You know, send me so glad send me see who me see today now because you start show up. I forgot to get the phone and make a telephone call and say, yo. All right, let me hear what the others say.
It's an exam too hard. They need to make the paper easier.
Yeah, but you see that, you know, but I'm going to say 6 alone.
All right, so
we get 6/0.
what does when we place it when we divide everything by the highest power, it would become 6x4 divided by x to the power 4, 25x to the power of x to the power 4, and 7x to the power x to the power 4, and same thing for the denominator. If we were to what's the word, simplify it based on what I say in the next step, the first thing that would be there is that the the two what's the term now, terms would cancel each other out. So the first one it would be 6.
Mm-hmm.
All right, so we go on to 23 x cube over x4. If we divide that, if we simplify that based on what based on what's already here, it would become 25.
Say what now?
No, sorry.
No, but no.
I mean, it would become 20, 25x over x.
So why are you why are you what you doing, Crosswell?
No, I'm trying to
You
work.
started
I'm
yes.
trying to yes,
Yeah,
I'm explaining the logic.
yeah, but you started off well and then you went off course. Yes, Colin.
I see how you simplify without working it out.
Okay, good job. Crosswell, it started off well, but then it went off course.
Yeah, so I was trying to simplify 25x3 over x4, and once you simplify that, you're supposed to get based on what I see 25 over x.
Crosswell,
And
you
then the
went
next
off course. Crosswell, stop. You are off course. You are off course. You're going last. You're gone into the wilderness, and the wildebeest them going come eat. The cannibals them going come eat you up. You need to come back on course. You started off well, and then it went off course. Anybody else see the answer?
Yes, sir, but I have a question.
I saw my work thought a while ago.
Okay.
So where did I go wrong? Because I was trying to explain the numerator side of the expression first.
I will tell you where it went wrong, but not yet. But look back at it. For the others, you didn't do that for the others. So I don't know why you're changing it for this time around. You never did it for the others. Nigel, I hear you. You said that you had to work it out.
Yes, I'm gonna transcend it, sir.
What answer did you get?
I'll get 6 over 0 equals 6, sir.
Okay. Anybody else?
Sorry, question.
Go right ahead, sir.
When you're doing this, right, is there a case where you will ever have two constants, like for the numerator?
Ask the question again, Alexandra.
Right, so of 6x cubed, 6x to the fourth power, right? Plus 25x third, yeah, plus 7, right? So now so the answer is 6 over 0, cool? What if, we did have a next constant in that numerator? Would it be a possibility that it could have?
If no, because if you get an next constant in, yeah, I could have give you +5. I could have give you +3, -2, -15. Yeah, no, would it change the answer? Alex, would it change the answer?
Well, I'm gonna think you understand me, sir.
You're asking me if I put a constant in the numerator, if it would affect the answer. Isn't that what you're asking?
That's not really.
All right. Okay. Clearly, I don't understand it. Go ahead again.
If you had two constants in the numerator. Isn't that what you're asking?
Yeah.
Right.
So let's say we did have
But
wait. Let me show you something. So replace the 25.
For this last one, you had 6x raised to the power of 4 plus 5x raised to the power of 4 minus 7.
Right.
That's what he was asking.
Yes.
Yeah, but I mean, 6x raised to the power of 4 plus 5x raised to the power of 4. That would have been 11x raised to the power of 4. Because that would not be a separate term. So I won't give you I won't give you similar terms disjointed. Meaning, I want to give you 6x to the fourth plus 25x cubed minus 2x to the fourth. No, that would be confusing. That expression would not be written in the simplified form. You notice all of these expressions are written in the simplified form in terms of all the x to the fourths are together, the x cubes are together, the x's are together. So no, don't expect anything like that. So I just saw a response a while ago, which is what I like. And that was the first response that I got that really sums it up for me. So what is the answer? By the way, Alex, you understand what I'm saying?
Yeah, man, I understand. Sure.
Okay. What's the answer for number 7? Numero 6. Siete.
That's 6, sir.
You got 6. All right. I'm going to come back to you, Nigel, because I heard when you said that. So I'm going to come back to you for an explanation. Anybody else for an answer?
Yes, sir, 6.
Okay. All right, Alex, I hear you. Anybody else?
6 over 0.
6 over 0.
6 over 0. Okay.
And it says,
Hold on, sir.
for
So
that
what
form, sir,
Uh-huh.
for that form, any number over 0, it means that the limit does not exceed such a thing.
Okay. All right. I hear you, my love, Moya Boo. You eat lunch today, Moya? You eat lunch today?
Sir, why have you?
Me ask you a question. No question me. Did you eat
Yes,
lunch today?
sir, yes.
We eat for lunch today, Moya?
Jerk chicken.
Craven. No, you're the real big bag.
Food in our class, sir.
Hey, Shadiq, you see what a big bag now, Shadiq, and I call in again, you know?
Might get 6 too, but I don't understand what make this different from the other ones.
That mean 1 or 2.
You, Nigel, and Alex.
Is it
You,
6
Nigel, and
over 0,
Alex.
sir, but I simplified?
I'm really?
That I shouldn't carry it from 6 over 0.
So you're saying to me that you simplify 6 over 0 and get 6? How you do that? Tell me what you do.
All right, that's a
I
fair
just
point.
get 6 over 0 then, sir.
Is it? Hold on.
I remember saying fool a while ago. So 6 over 0.
You know,
Answer.
you know, one of the things I pride myself with, I just ask the questions. And
Sorry.
then no, yeah, go ahead.
Sir, I just have a random memory from primary school, and my
Mhm.
teacher tell me say if the denominator smaller than the numerator, it can't carry.
It's very random. That memory is very random.
Man, I don't know what it have to do with this, but it's just flashing on my memory. Can't see my teacher face and everybody in that class for some reason.
Okay, all right, I hear you. Nigel, I'm writing that point a little more in Nigel. Tell me how you convert 6, Nigel, over
the.
They say me why you fit Alex, help him out, you know, because he tell me 6 2, you know, Alex. So you have to help him
I
out.
missed it.
Alex, don't tell me no about a mistake.
This is the honest mistake.
Sir,
Earlier when we worked it
realize
out,
says
I would
would
have
be
1 over
undefined.
1, sir.
You see,
You
you
question, we got 1 over 1, and I
Yes.
thought we have to simplify it with a 1 over 1, so that would equal to 1. So now I work it out, I'm gonna get the 6 over 0. I'm gonna just say, 6.
Well, guess what? Nigel and Alex, the burger we're not gonna buy later, now go taste good. So better not don't buy none. Now go taste good. All right. Now, Shani, sorry. Shan, you get the answer, Shan?
Sir?
What do you get for the answer?
Sir, to be honest, I got distracted.
Yeah, man, you're fast on calling and get distracted. This is how life is, though.
Sir, question.
Yes, please, Alex.
All right, so I'm pretty sure that division by 0 would equate to an undefined number.
Oh, so no Google come into
No.
play and now you so much time you change your mouth on me, Alex?
No, man, just still no, sir.
No, man, yeah. But you're correct now, though. You're correct. All right.
Sir, the memory they have it placed, sir. I know something wrong. You can't have 6 over 0. I never heard that before.
Okay, interesting.
Technically then, sir, everybody did wrong then.
For the Moya dropped something in the chat, and Moya says, sir, you know she talk very dainty.
Yeah, it's undefined.
Yeah,
Yeah.
undefined.
Yeah. And should all that then, you know, make Maya catch you out the road.
See? Now we know about me.
Make Maya catch you out the road.
Corrected.
Maya done you. But anyhow, serious business now.
So,
Kenny.
So wait. So the answer is when x approaches infinite, it undefined.
Yeah, no. When once you have a zero in the denominator, it becomes undefined.
Undefined. Okay.
The pen is not working in here. I can't spell define, but it's just not working.
I believe you, sir.
All right. So remember now, students, very, very important.
All in that.
Hear me out. If you had placed only 6/0 and it's a 5 marker, you'd have gotten only 4 out of 5. Because you must therefore then conclude that the limit is undefined. The limit is undefined. Now, how do I explain something that is undefined? I am going to trouble those people. Yeah, man, you have to do it, because this is one of the constraints in math that is it's fundamental. Remember, Colin just a while ago say, remember something from elementary? It is fundamental. You can't divide by 0. It's fundamental. Anything divided by 0 is undefined. It is fundamental. Let me yeah, if the limit does not exist, it's still undefined. Yeah, so that is fine. All right. Let me side talk you with something. For those of you who are taught Foundation Concept 3, and for those of you who are taught, well, only pre-calculus. Yeah, because I'm a business calculus student. And those of you who are taught business calculus would have gone to something like y2 minus y1 over x2 minus x1. And this one talk about the slope, SLOPE, or the gradient. All right, now, up here so is the rise. Down here so is the run. Now, I sir, I'm going to say something, but I don't, nobody come for me. You see the people them Oliver Portmore? Them decide to them want to go upstairs, and rightfully so, I'm glad for them. But the staircase them use to connect the ground floor to the upper floor, ja. It's steep. JJ, leave me alone. It's steep. So sometimes, and this is real talk now, you know, sometimes people who live in Portmore and complain about back problem and them have upstairs and downstairs house, they are the ones causing the strain on their backs because the staircase is way too steep. It puts a strain on your back. Hear me out. The rise is this. The run is this. That's the run. This is the rise. That's the height of from the ground floor to the bottom floor. The run is the distance how the staircase being spread out. In Portmore, you don't have enough space. So the run are gonna be small. It's when a Brighton can spell. It's when a Brighton can spell. All right. I was thinking about something else that is undefiled. But yes, it's supposed to be undefined. Thank you.
Yes, sir. When we go, we do this in a probability of statistics. Man,
Yeah,
that's
right. Right, supposed to be. So when you look on the something now, them don't have enough run space. Them don't have enough run space. So them drop the base of the something to a little bit until them recognize it. But if we do that, so the door now go swing. We could put the door up on the other side and then cut it even a little bit closer. So what is happening is that this piece here is going to 0. The denominator is going to 0. Now, when the denominator going to 0, this is what the staircase will look like. And nobody can climb something that is vertical. No, 0 over 1 is 0, but 1 over 0 is undefined. Right? We can't climb something vertical like that. So ideally, this is where you and I walk, and that is good on the back. But when we have a slope now, we can do what it is that we need to do. Like Excelsior Community College, when you go on blocks A or block B, this is how their staircase is. They don't have much space, but they do something like so, a little steep something so, and then put a landing. And then go so. Because if they were supposed to go so, there's something that be way too steep. So what you see the man them do is not do this, but they do this. And put a landing here so to make life so much better. And guess what? Them utilize the space under the landing for storage. So it's mathematics, you know. It's mathematics that we do. So it's when you're building up, when you're extending a house in Portmore, you have to go show the mathematics when you learn at college. So what it will be best for Portmore people to do, and Portmore people, listen to me. And I wouldn't even say only Portmore people who live in a scheme. So like,
our houses them built up.
Huh?
So our houses them building on my scheme.
Yeah, that's exactly what I was going to say. It occurs if you live in a scheme house. So like if you live in like Glendale and you live like Hewenden, you know, those scheme places. I know Portmore is more scheme, you know, where the wall make a ground and then put up. Yeah, man.
It's really bad. Like, my father run me from downstairs and tell me to go live upstairs. He can't climb them stairs every day.
but I'm telling you, it's true. Something I'm telling you, real something. So what I would recommend for people is to put in a spiral case, a stairs, so that when you go, you walk in circles. It is easier on the back, so much more easy on the back. And I know quite a number of peeps who, because them do what them supposed to do right there, so mash up them back. All right, it's mathematics. So it is going to be 6 over 0. Once you have 6 over 0, it's going to be undefined. You cannot have a 0 existing in the denominator. However, you can have 0 over 6. 0 over 6, all right, because 0 over 6 is 0. You can have a 0 existing in the numerator, but you can't have it existing in the denominator. Put it this way. Final example on this, why it is undefined. Some of you, when you put on a calculator, it says math error. All right. So once you say something about math error, it means that it's undefined. But put this stuff. I drove up to Gordon Town the other day. Gordon, and this was in the peak of the election period. Went somewhere up Gordon Town, and while I was driving, I looked at some property to the right hand side on the very narrow road. That the roof of the property is in line with the road. You know, so me now live there, so because anybody run off of the road right, it's right by my roof it a come. Me now do it. But guess what? On Mount Russell, you know, go all 3 years on the old road, on Mount Russell, you have people who build their houses like that, and their car is
Junction.
Same with junction too?
Junction. Yes,
Same
sir.
thing? Yeah, man. And guess what the people them do a Mount Russell? Them use the top of the roof as them garage and then park the car there.
Yes, they do. It looks so convenient to me. But man,
It
understand
does.
what you say.
It does. But me not living there.
Man, truck run off of the hill.
Oh, stop it. And that's exactly what I think about. That's exactly what I think about that. No. So what's the point I'm making? I just give you an example that the car can hold on top of the roof. So a big boulder, one round stone, can sit on top of a roof. But guess what? You can't build on one round stone because it means say you can only if you step on one end of it, the house will go topple over. Okay, don't have anywhere to support it. The only way you can step in the house is unless you go right in the middle of the house where the stone is. Anybody can see that? Picture it?
Yes, sir. Clear as day.
Yeah, man. So you can't have a zero existing in the denominator. It's undefined. Can't work. But you can have a zero existing in the numerator. In the numerator. All right. I'm going to. I did say I was going to. No, that was it.
Why you want me my brain confused?
No, man. Whatever is left, I can juggle that. Matter of fact, I may send one of those as your homework piece. But I am going to stop there for tonight and ask if there are any questions, just for me to mop up, because remember the weekend is coming up, so I don't want you to go into the weekend with unanswered questions. Any questions?
Yes, sir.
Go ahead.
You did say you were going to show us how we can identify the answer by observation, sir. Can I wait for that one there?
All right. I was calling Kenny, but Kenny vexed with me. Should not talk to me at all. Kenny.
Sir, see me here, sir, me have to jump off for rest my head. Jesus. Sir, me just come back on.
All right. So are you able to see it now?
Yes, sir. Sir,
Yeah.
is there anywhere you can send me go watch one YouTube video or something so I'm ready for class tomorrow? Cause I tell you, boy.
All right, let's go to my channel and look. All right, so business gal, I'm happy that you're here because I did promise you last night in class. Sorry, not business gal. I had a pre-calculus class last night and I promised them that I was going to upload their videos. And as promised, I took my tablet with me and try as I may, it just nothing happened. And then Colin is saying to me now that there is a problem with the uploading of the video. So that's why I can't upload any other videos yet, because I did actually take the tablet with me all this evening, and it just really wasn't happening. All right, let me show you what is happening here. Oh goodness. Can somebody just drop the link to my? Last night I looked it up because last night the students asked me the same question.
But sir, is your YouTube channel?
Say it again?
Isn't it your YouTube channel?
What do you mean by that? Okay, thank you. You see, it's only love shaming the teacher because here him now with him smart self. Isn't it your YouTube channel and you don't know your own channel ID? It is Mark Shand 5 something.
Sir. 5088, sir. I was sending it, but I sent it to you instead.
Okay, 508. I know it was something like that. Says Mark. Thanks. Send it again for me, please, Shan. So just look for it and just look for the if you're going to business cal is MATH3601, and you'll see some of those very questions that I would have done and on these areas. But let me show you this quickly though. A rockstone. Okay, let me show you this quickly.
Thank you.
No problem. Look at this. So what it is that we're doing, we're identifying the term with the largest power. Let us look at number 3. Which term has the largest power? Good job. That's the term with the largest power. So when these are cancelled, what am I left with?
2/5.
In number 4, which is the term with the largest power?
3x to the fourth power and x over, no, 7x to the fifth power and 2x to the fifth power.
Not just 7x, but negative 7x. And then those cancel, so that's why I'm having negative 7/2.
Sir, sir, true?
Duh. And then
Just never see that.
and then when you look at the other one, the highest power one is going to be this. Bam, 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 bam. And when you cancel this and cancel this, you can have 4/2, which is 2. And then when you look at the other one now, you're going to have, you have x to the 5th. If you might tell you, say, can't go in one or the other, don't. Hello?
Yes, sir.
Good. Is there any x to the 5th in the numerator?
No.
No, sir.
And that's why I have 0. And then you can have the 1. And then 0/1 is going to be 0. And then
Sir, the explanation I gave you for that, it's correct, right?
the top one, I responded to, the top one I understand, but I don't understand what you asked me in the bottom one.
I'm give about the explanation for the bottom one.
Oh, you gave it back to me? All right, I soon look at it. And then this one here now, we're looking at x to the 4th. You see, do you notice where, you see in number 6 where you don't have a x to the 5th in the numerator? You're going to replace it with 0. So it's like you're having 0x to the 5th. Right? And then you don't have an x to the 4th in the denominator here. It's like you're having a 0x to the 4th. And that's how we get 0/1 in this case and 6/0 in the other case.
Okay, I understand how you get the rest of them. Yeah, but like when my brain tired, but now I'm gonna remember the short-hand degree. Nothing like.
Oh, yes, Alex. If that's what you were asking me before, the answer is yes. The answer is yes.
Cool.
All right. So let me wrap up nicely for you. I see people leaving on a rapid. Let me wrap up nicely for you. The questions that we've done tonight, the topics that we've covered tonight, are very easy. They look difficult because they have lots of x's and numbers and divisions and limits and them something there. But when you're working and twerking, you recognize that it is really not difficult. Really not difficult. You just have to put your mind to it. And guess what? When you're asked to calculate the limits of functions like those, the indeterminate ones, and incidentally, it works only for indeterminate ones here. It don't work for the other one them. So don't want to look on the limit and say, oh, but we can't figure out the answer here, and then they say the question can't work. No. It only works for those that are indeterminate. All right? And in particular, indeterminate infinity over infinity, positive infinity over positive infinity, and negative infinity over negative infinity. It doesn't work for the other one. And that is it. Students, for the mock exam, I am expecting topics on what it is that we've done here on Monday, on next class. God's willing, I'll be continuing here, do a quick recap and looking briefly at the negative infinity over negative infinity. Business Cal, tomorrow, God's willing, we are going to reinforce what it is that we learned tonight. I'm going to teach you the 0/0 indeterminate form. The Calculus 1 students just completed that this week. So the Calculus students have gone through the 0/0, the positive infinity over positive infinity, and only now have negative infinity over negative infinity. Business Calculus, my aim is to do all of those for doing tomorrow's session. Any questions? I am done for the night. I really enjoyed my class tonight. I really hope you guys enjoyed and learned something. Any burning questions?
So, sir, go.
Yes, sir.
Go.
Sir,
Go.
can I ask a question?
Go.
All right, so I just want some clarity. I'm a business calculus student. When it's classes and when or how we get the links for classes.
All right, link me tomorrow for that. The link for tomorrow is supposed to be out already. Is anybody seen the link for tomorrow? Okay.
Sir, we're still not able to select the question here.
All right. I sent the message to the head and the 2 assistant heads in School of Business. I don't know what happened. And Dahlia reminded me, but today was just a up and down something. And did I go over there? I went over there, but I never remember to ask them. All right, Buduf Baf, what am I checking for? All right. It's all right. I will get something to you. If there's no link, I will just get access to some Zoom so we can meet nonetheless. So we don't have to worry.
First, so it's just Friday and Saturday we have classes.
No, man, when they come tomorrow, we'll talk about that.
Okay.
We had a class one day this week, early morning class, 5 o'clock, and people came out and we learned. So tomorrow we can do some mopping up. Anyhow, it was nice having you. Have a wonderful rest of the night.
Sir, I didn't
Sir, can you share this
question.
document with us as well, please?
Yeah, man, I will most definitely do that.
Sir, in the chat, Kimaya asked a question that I also want to confirm. She asked if she was sir, is that undefined or well, yeah, but if she said if it was 0/1, the answer would be defined. Would it?
Yeah, and it should be defined as 0.
So we have to state defined at the end of that.
No, you don't have to.
Because it already implies that it's defined.
It's defined, right? It's just the one that is undefined. You can say, yo, ropes undefined.
Okay.
Sir, just one last quick question, sir. The Saturday class is for everybody, sir?
No, just for the business class students.
Sir, so can't
Huh?
So like if I want to join, I can't join.
Yeah, man. If you wanted, it's just like I invited them. If you want to join tomorrow, you can join, because what I'll be doing with them tomorrow is the same thing that you guys are doing. So the invitation is open. So any of the Calculus 1 students want to join tomorrow, feel free. Because I invited the business class to join in your class, so you can come and join in for the month too. Not a problem. The only condition is Carry Burger King. But never mind, I'm joking. No,
Tomorrow is going to get that virtual.
Thursday it's 9 to 12.
They're about-ish. They're about-ish, my dearest. But you're good, man. Come in and join. As many of you, and you can tell your other classmates.
AM, sir?
Huh?
9 AM?
Yeah, we're starting at 9 tomorrow, yeah.
Sir, so that's every Saturday, right?
Every Saturday up to, they're doing a block scheduling, so every Saturday up until the end of October. I was in a meeting the other day and they said that the exam may be the last week of October, and I'm begging them, please, let it be the first week of November.
Oh,
and I spoke with somebody. Don't worry about it. You'll be ready. You will be ready. Trust me. I'm telling you.
Name, amen. We will be.
You will be ready. So I don't say pen. Where pen there?
Sir, they must stress them drop asleep.
Jeez on peace. Tell Pen to make sure she come. Yes, please.
So I remember when we were doing the pre-call the other day where your teachers from the back to the front. Sir, could I use maybe use that technique this time around?
I could, but I'm gonna need this first piece here that we're doing to get to the back, if it's what I'm saying.
Oh, okay.
So I have to do this piece. But based on what I'm doing here now, man, so I soon finish with this piece here, and then we're gonna move into some integration and differentiation. And then at that point in time, I'm going to invite the Calculus 1 students to come, because they're going to be doing lots of integration and differentiation. So I just want to get through, this. What we're doing here now is foundational. And then after this foundational, we're gonna move into differentiation and integration, because I can't, if I move to the back, Shan, you're not gonna able to move anything, because you have to know how to integrate and differentiate. So when I reach integration and differentiation, everything else I would do is when it involves integration and differentiation. So you have to know how, I know have to introduce integration and differentiation to you in a way that you know how to integrate and differentiate. So what I'm doing here now is just foundational to build up to the integration, because when I'm doing the integration and differentiation, for argument's sake, we're going to get things like, just a quick something here, you can get things like y is equals to 4x cubed plus 5x. Come on. All right, this is not writing. Okay, plus 5x, and you have to find dy by dx. And, you can do some stuff, 12x squared plus 5. And I'm going to ask somebody for something. And you have to do that in order to do, it's like when you do pre-calculus, you have Kramers that come as a must-have. In calculus 1 and in business calculus, you have something that is called stationary points. That is a must-have. And that is like about 30 points. It's like a 30-mark question, between 20 marks and 30 marks. So I have to teach you that, but I can't teach you yet because you need to know how to differentiate and integrate. So tomorrow we'll sort it out, man. I'm not good. Just make sure you have like a breakfast and come ready to do some work. Peace out. Later.
All right, sir. Good
9
night.
o'clock. 9 o'clock.
9 o'clock.
Yeah, man. Yeah, if not, I'll send off the link to you guys.
All right.
All right, cool.